This video, we'll be talking about binomial expansion. In the previous video, we have talked about the Pascal's triangle and how to use Pascal's triangle for the for expansion. It's not about binomial expansion. Remember that in our Pascal's triangle, we have already mentioned that we have something like 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and so on and so forth. And this is Pascal's triangle. And let us quickly do a little bit of revision on how to use Pascal's triangle for expansion. Let us say we have something like a plus b raised to the power of 2, for example. What you're just going to do is what? This one we increase with the factor. We have the highest power, and this one we have the lowest power. And you'll be taking what? You'll be taking your coefficient from this place. So we have something like 1. That'll be 1, a raised to the power 2, b raised to the power 0, plus 2, a raised to the power 1, b raised to the power 1, plus 1, a raised to the power 0, b raised to the power what? B raised to the power 2. Let me write that one very well. 1, a raised to the power 0, b raised to the power of 2. And we're going to be having something like a squared plus 2ab plus b squared. That will be our expansion for this particular one. So this is how to use Pascal's triangle. We are just trying to revise it. So now, how are we going to use binomial expansion itself? Now, you see, we have binomial theorem, like the equation for binomial theorem. But before we go there, we are going to use the concept of combination to look for a particular term in or a particular term of a binomial expansion. But before we go there, we have a particular formula. We have a formula for calculating, or let me call it a formula for binomial theorem itself. And what is that formula? Now, you see, this, if you want to expand binomial expansion with large power, for example, 1 plus x raised to the power of 32, 1 plus x raised to the power of 50 something, you understand? Using Pascal's triangle is not recommended because we are going to generate a large number of rows of triangle. You understand? So there is now an alternative method to use, and we call it binomial theorem. You see, binomial theorem helps us to expand a plus b raised to the power n if n is a large number, or n is a fraction, or n is a negative value. N is a negative value. So if you are given n as a negative value, you cannot see that on the Pascal's triangle because Pascal's triangle, all of them are whole numbers, you understand? And if n is a negative number, you understand, you cannot find that as well on the Pascal's triangle because all of them are positive integers. So using binomial expansion or the binomial theorem help us to expand this thing if n is a large number, if it is a fraction, or even if it is a negative value. That is the advantage of using binomial theorem or the binomial equation in expansion of mathematical expression. Now, you see this binomial expansion or the binomial theorem itself, it's quite large, but you have to get used to it. Now, let us say for an example, you have something like a plus b raised to the power of n. Now, what is the binomial theorem for this particular expression? It is now going to be, you see this first one, you are going to take it, you know, this one is going to take the highest power, which is n, and this one is going to take the lowest power, which is 0, and anything is power 0 equals to what? Equals to 1. So we are going to take the first one. The first expression will be a raised to the power of n, b raised to the power of 0. But we know that b raised to the power of 0 equals to 1, so we don't need to put it there. So that is a raised to the power of n. You understand? Now, plus, you now see this n that is here. This n that is here will now come to the back. You understand? In the next expression, then you are going to subtract 1 from this n. You understand? Remember, from the Pascal's triangle, we know that a will decrease by what? By the factor of 1, decrease by 1, and b will what? B will increase by what? By 1. You understand? So that will be equals to what? That will be equals to this n will come to the back. That will be n. You understand? A raised to the power n minus 1, then b raised to the power what? B raised to the power 1. You know, it is b raised to the power 0 here before. So you increase it by 1, it becomes what? It becomes b raised to the power 1. Do you understand? Now, That is the next one. Therefore, the next one is now that we have n here already. So this n minus 1 will also come to the back to make this n. And you're going to subtract 1 from here as well. It becomes minus 2. Then this one increased by 1 becomes 2. You understand? So we are going to be having what? We're going to be having n, which is the n that is here already, into bracket n minus 1, which is the n minus 1 that is here, a n minus 2. You understand? Then b raised power 2. Therefore, you're going to be having something like what? Everything divided by 2 factorial. You understand? Everything divided by 2 factorial. Are you getting me now? Now, the next one would now be what? The next one will be plus. This n minus 2 will do what? We come to the back to make this n minus 1. And it becomes what? It becomes n minus 1 into bracket n minus 2. Then it becomes what? A n minus 3, b3, everything divided by what? Everything divided by 3 factorial. And that is how it goes till it reaches what? Till it reaches b raised power of n. You understand? Till it reaches b raised power of n. So one thing about it is that you start with a raised power of n, you end with b raised power of n. You understand? Now, let us take for an example. Now, please note of these factorials, 2 factorials, 3 factorials. Now, which means if you want to do the next one now, it will not be what? It will not be n into bracket n minus 1, n minus 2, abi, n minus 2, then into bracket n minus 3. Therefore, we're going to be having a n minus 4, b raised power of 4, everything divided by what? 4 factorial. The next one will be n minus 1, n minus 2, n minus 3, n minus 4, a n minus 5, b raised power of 5 divided by what? Divided by 5 factorial. You understand? So this is what we have. This is the binomial theorem itself. You understand? So it's continuing like that till it reaches what? Till it reaches b raised power of what? B raised power of n. You understand? Now, let us take for an example. Remember that when I expand this, I have what? I have a squared 2ab plus b squared, right? So let us take for an example. I was told to expand a plus b raised power of 2. A plus b raised power of 2. In this case, I was given a plus b raised power of what? Raised power of 2. And I was told to use binomial expansion. You understand? What will it be? I'll just say equals to what? The first one will be what? A raised power of n, right? Let me write it here. A raised power of n plus a raised power of n minus 1 b plus n a raised power of n minus 1 plus, let me write it very well, plus n a raised power n minus 1 b plus n into bracket n minus 1 a n minus 2 b 2 divided by 2 factorial, right? So this is a raised power n. What's my a raised power n? That's a raised power 2 plus n, which is 2, multiplied by a n minus 1, that is 2 minus 1, therefore b, right, plus n into bracket n minus 1, that is, what's my n? 2, right, into bracket 2 minus 1, that is 1, right? Now a, what is my a? That is a raised power n minus 2, that is 2 minus 2, therefore I'm having b squared, everything divided by what? Everything divided by 2 factorial, which is same thing as 2 times 1. So whenever you see the word factorial, if you have 3 factorial, it's same thing as 3 times 2 times 1. You understand? You are just coming down. Whenever you see 4 factorial, it will be 4 times 3 times 2 times 1. 5 factorial will be 5 times 4 times 3 times 2 times 1. You understand? So we have them like that. And you have to know that 0 factorial equals to 1. Please, that one is very, very important for you to know. 0 factorial equals to 1. You can press it on any calculator. Now, what we have here? We have a raised power n. Now, n minus 1, that is 2 minus 1, right? So that will give us what? That will give us a raised power 2 plus, now, n minus 1, which is 2 minus 1 equals to 1, right? That will give us 2 raised power 1, b raised power 1, plus, now look at this. These 2, we cancel these 2. We don't need it again. And a raised power 2 minus 2 equals to what? We give us a raised power of 0, b raised power of 2. And that's the same thing as a squared plus 2ab plus b squared, which is the same thing as what we have here when we use Pascal's triangle. But please note, whenever you are given a positive integer as your power, a positive integer as your power, you don't need to use binomials expansion or the binomials theorem. You can just use Pascal's triangle for expanding it. You understand? But if you're having a finite series that is a negative value, you understand, and therefore you're going to be having what you're going to be using binomials expansion. You get me now? For example, we are told to look for the binomial expansion of a plus b raised power minus 2, for example, raised power minus 2. But if you check very well, there is nothing like minus 2 on this particular Pascal's triangle. Therefore, you are going to use binomials expansion. You understand? And that will be equals to what? That will be equals to a raised power minus 2, right? Plus minus 2 into bracket a raised power minus 2 minus 1 minus 2. That will be minus 2 minus 1. B raised power what? B raised power 1, right? Now, that will be equals to what? Plus a raised power, let me pause this, plus, that will be minus 2 minus 1 we come to the back, right? That will be minus 2 minus 1. That will be minus 2 into bracket minus 2 minus 1 and what? A raised power minus 2, then b raised power 2, everything divided by what? Everything divided by 2 factorial. And that's how you are going to be doing it. And at the end of the day, you are going to be having infinite series because it won't finish. You understand? You have minus 2 minus 3 minus 3 minus 2 minus 4 minus, you understand? It's continuing like that. Therefore, you are going to be putting what? You are going to be putting 3 dots at the back. And that 3 dots shows that what? It is an infinite series because it does not end. You understand? It does not end. So that is what? That will give us a raised power minus 2 plus, or you can even say minus 2a raised power minus 3b plus, that will be minus 2 times minus 2. That will be equals to plus 4, right? Plus 4 a raised power minus 4 b raised power 2, everything divided by what? 2 factorial. Then it continues like that. You are going to put that dot 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 to show that it is an infinite series. So these two cancel these two. I'm left with what? I'm left with 2 a raised power minus 4 b raised power 2. So can you see that it is not the same thing as what I have when I use a positive integer? You understand? In positive integer, I have a squared plus 2ab plus b squared. But this one, I'm having a raised power minus 2 minus 2a raised power minus 3b plus 2a raised power minus 4b squared. You understand? Then it goes like that, like that. So that is how it works for binomials expansion or the binomials theorem. But we are not going to that place yet. Let us say we are not looking for a particular term of a binomials expansion, a particular term of a binomials expansion, a particular term of a binomial expansion. Now, you see in this particular one that we're looking for a particular term of binomial expansion, we'll be using something we call combination. You understand? We'll be using something we call what? We call combination. And that formula is C n r a raised power n minus r, then b raised power r. You understand? That is the formula that we'll be using to look for a particular term of binomial expansion. And you see this CNR, it is what we call combination. We have two of them. We have combination and permutation. But this one here is combination. We are using combination. Now, how does combination work? Whenever you see the word CNR, it is now equals to what? It is now equals to n factorial divided by n minus r factorial r factorial. You understand? Therefore, for example, if you have something like 7, let me say 7 3, for example, 7 3, C combination 7 3, it will now be equals to what? It will now be equals to 7 factorial divided by 7 minus 3 factorial 3 factorial. You understand? And that will be giving us what? That will be giving us 7 factorial divided by 7 minus 3 equals to what? Equals to 4 factorial, then 3 factorial. So it is not hard. you're just going to say, you remember I told you that if you're having 5 factorial, it is 5 times 4 times 3 times 2 times 1, which means 7 factorial is same thing as 7 times 6 times 5 times 4 times 3 times 2 times 1. And we have in the denominator 4 factorial, that is 4 times 3 times 2 times 1. And we also have 3 factorial, that is multiplied by 3 times 2 times 1. Now look at it. 4 cancel 4, 3 times 2 times 1 cancel this one, right? 3 here 1, 3 here what? 3 here 2. 2 here 1, 2 here 1. And we are left with what? We are left with 7 multiplied by 5. And that's equals to what? That's equals to 35. You understand? Which means C with 7 combination 3 equals to what? Equals to 35. As simple as that. Now, let us now say we are looking for a particular term. So if you are looking for a particular term under binomial expansion, it means we are looking for r plus 1 time. R plus 1 term. So let's take for an example. We are told to look for let's say look for the expansion, the 7th term, or let me say 4th term rather, 4th term in the expansion, 4th term in the expansion of p plus 2q everything raised to power 10. So you are looking for the 4th term in this case. So what you have to note is that since we are looking for the 4th term, it means that r plus 1 equals to 4. That is the meaning. Now, which means what is our r like that? Just take this one to the back. That is r equals to 4 minus 1. And that's equals to what? R equals to 3. Which means we are just going to say it's the same thing as what? It is the same thing as C n, which is 10, 3, right? What do I call it? A n r, that is A 10 minus 3, then b what? Br, that is b3. The same thing as c 10 3, a raised power what? A raised power 7, right? B raised power what? B raised power of 3. Now in this case, they say we should look for p plus 2q. What's our a? Our a equals to p. Our b equals to what? Equals to 2q. As simple as that. You understand? Therefore, if we want to look for the 4th term in this case now, we have already have everything that we need. Therefore, we are going to be saying what? We are going to be saying is the same thing as what? Is the same thing as 10 factorial. Sorry, let me change that ink. That is 10 factorial divided by 10 minus 3 factorial, 3 factorial multiplied by p raised power 7 multiplied by 2q raised power what? Raised power of 3. So let us solve this particular one first. Let us solve it first. So 10 factorial divided by 10 minus 3 factorial equals to 7 factorial, then 3 factorial, right? And that will be equals to 10 times 9 times 8 times 7 factorial, which is 7 times 3 times 3. That is 7 factorial multiplied by what? Multiplied by 3 factorial. So 7 factorial cancels 7 factorial in this case. And 3 factorial is what? 3 times 2 times 1. Abi? 3 times 2 times 1. 3 here 1, 3 here 3, right? 2 here 1, 2 here 5. That is the same thing as what? 5 times 3 times 8. And 5 times 3 times 8 equals to what? That is equals to 15 times 8. I think that is equals to 700. That's equals to 700, right? That's 760 rather. Let me press your calculator. Sorry. Please hold on. Let me press the calculator so that I can confirm what it is. So that is 15, right? 15 multiplied by 8. Sorry. Let me see if there's no error. 10, 7, 8, 9, 10. That's 10 times 8. I'm coming. 10 times 8. Yeah, I think we are correct. Yes. Yes. That's equals to what? Sorry. What do I have here? What do I have here? That is 15 times 8. 15 multiplied by 8. That's equals to 120 rather. Not 760, sorry. 120. So that's our 120, which means all this one now is what? 120. So we are coming back here. It's the same thing as 120 p raised power what? P raised power 7 p raised power 7. And remember, 2q raised power 3 is the same thing as 2 raised power 3 q raised power what? Q raised power 3. Abi? And 2 raised power 3 equals to what? Equals to 8. That is multiplied by 8, 120, multiplied by 8 q raised power what? Q raised power 3. So 120 multiplied by 8, we are going to be having what? We are going to be having 960 in this case. So that is equals to 960 p7 q raised power what? Q raised power 3. So that is our answer. This is our what? This is our fourth term. These are our fourth term in the expansion. You understand? So that is how it works. So let's say for an example, you're told to look for the seventh term. Look for the seventh term of f 5x minus b 5x minus b raised power of what? Raised power of 8. You understand? Which means seventh time. You are looking for the seventh time. Which means what? Which means our r plus 1 equals to 7. Therefore, our r equals to what? 7 minus 1, right? And that's equals to 6, right? Therefore, you can solve it the way I solve it. That will be equals to what? That will be equals to 8, 6, right? N minus what? N minus which is 8 minus 6, that's equals to 2. 8 minus 6, and b raised power what? B raised power 6. And that will give us what? 8 factorial divided by 8 minus 6 factorial 6 factorial multiplied by our a equals to what? 5x, everything is power what? Everything is power 2, and our b equals to what? That equals to b raised power what? B raised power 6. Now 8 factorial divided by this, that will give us what? That will give us 8 times 7 times 6 factorial divided by 2 factorial multiplied by 6 factorial. So 6 factorial cancels 6 factorial. 2 here 1, 2 here 4, right? That is multiplied by what? Multiplied by the 5 that is there, that is 25 x squared multiplied by what? Multiplied by b raised power 6. B raised power of 6. So if you multiply everything here, that is 4 times 7 times 25. 4 times 7 times 25. Let me multiply it here so that I'll confirm. 4 times 7 times 25. That's equals to 700. So that's equals to 700 x squared b raised power 6. And this is our answer for the seventh term of this binomial expansion. So as simple as that, that's how binomial expansion works. Thank you, and follow for more.